All right, this one should be a little bit easier because the denominator or the divisor is x minus 3. When we're doing our division, we can actually use synthetic division to get the division statement. So this time, I'm just going to use synthetic division really quickly and just setting it up here. And then just remember, first number drops through, then we multiply 3 times whatever is on the bottom to get the next number, and it's always adding going down. So there is negative 49 is the remainder. The 1, 7, and 5, because this was x cubed divided by an x, I know the highest power is x squared, and then it just goes down by x every time. So we got the quotient and the remainder. We can write out the division statement. So it's the quotient, x squared plus 7x plus 5 plus the remainder divided by the divisor. Now what's nice and what is always going to happen is this little piece of the remainder divided by the divisor always goes to 0 as x goes to infinity. So in this case, that negative 49 is totally insignificant. As x gets huge, as x goes to either positive or negative infinity, it's going to be just a massive denominator and a tiny little numerator, so it's got to go to 0. So that means that whole piece goes to 0, and our asymptote this time is a quadratic. So I know it's y equals x squared plus 7x plus 5. That quotient is the asymptote. So here I've graphed the y equals x cubed plus the whole rational function there is graphed, and I'm just kind of adjusting the screen so we can get a good look at it. It doesn't really look like a parabola, but as we zoom out, as we get farther and farther, it starts actually looking like a parabola. Now, when we're way out, we barely see that vertical asymptote at 3. It really just looks like a parabola, where in the middle there's a funny little thing. So now I'm just going to graph the quotient. So y equals x squared plus 7x plus 5, and it's exactly, it looks almost like it's dead on top of it. So I'm just kind of making it a dotted line so it looks like an asymptote, but they're right on top of each other. If we want to look, so I called the original f of x and the asymptote g of x. What I'm showing here is look at how the values, the bigger the number is that we put in for x, for f and g, the closer those two values get. So it's basically this idea that when we're close, you got that asymptote at 3, the two functions doesn't really look like a parabola, but as you zoom out for large values, this rational function looks more and more like this parabola. So here I'm just kind of sketching there's just a general parabola, and I'm just kind of making it look like this. Our sketches aren't going to be super important. The important thing here is that we find this asymptote, which this time that parabola is the asymptote, and we're going to find all the components. Sketching, really, we're mostly going to just be sketching with Desmos. Oh, just remember, because it is plus or minus infinity, it goes towards the asymptote for large values of x or for very small values of x. And this is also called our end behavior. As we go way to the right or way to the left, to the either end of the rational function, it looks like whatever the asymptote is, which is the quotient of the division.